Good morning, everyone. I am Kwek Sin Ung. My metric number is 75342, a mechanical engineering student from University Malaysia Sarawak. Thermodynamics can be defined as the science of energy. The name thermodynamics stands from the Greek word therm, heat, and dynamic power. One of the most fundamental laws of nature is the conservation of energy principle.
Conservation of energy principle states that during an interaction, energy can change from one form to another, but the total amount of energy remains constant. That is, energy cannot be created or destroyed.
Example of the conservation of energy principle. A person who has a greater energy input, food, than energy output, exercise, will gain weight, store energy in the form of fat, and a person who has a smaller energy input than output will lose weight. The change in the energy content of a body or any other system is equal to the difference between the energy input and the energy output, and the energy balance is expressed. For example, a rock falling off a cliff pick up speed as a result of its potential energy being converted to kinetic energy. Now I'm talking about the first law of thermodynamics, second law of thermodynamics, classical thermodynamics, and statical thermodynamics. The first law of thermodynamics is an expression of conservation of energy principle. The first law asserts that energy is a thermodynamic property. The second law of thermodynamics states that it asserts that energy has quality as well as quantity. The actual process occurs in the direction of decreasing quality of energy. For example, a cup of hot coffee left on the table eventually cool, but a cup of cool coffee in the same room never gets hot by itself. The high temperature energy of the coffee is degraded once it is transferred to the surrounding air. Classical thermodynamics states that a macroscopic approach to the study of the thermodynamics that does not require a knowledge of the behavior of individual particles. Statical thermodynamics states that a microscopic approach based on the average behavior of large group of individual particles. There are many application areas of thermodynamics related to engineering practice and our daily life. I will explain how air conditioning systems apply the principle of thermodynamics. There are some operating principles based on air conditioning system, that is refrigeration cycle, heat pump, evaporative cooling, and free cooling. First, I will explain refrigeration cycle.
A simple style diagram of refrigeration cycle. The first is condensing coil, the second is expansion valve, the third is evaporator coil, and the fourth is compressor. Refrigeration cycle cooling in traditional AC system is accomplished using the vapor compression cycle, which uses the forced circulation and phase change of a refrigerant between gas and liquid to transfer heat. The vapor compression cycle can occur within a unitary or pad piece of equipment or within a chiller that is connected to terminal cooling equipment such as a variable refrigerator floor terminal or fan coil unit on its evaporator side and heat rejection equipment on its condenser side.
Second, I will explain heat pump.
Heat pump. Some air conditioning systems have the option to reverse the refrigeration cycle and act as heat pump, therefore producing heat instead of cooling in the indoor environment. They are also commonly referred to as reverse cycle air conditioner. The heat pump is significantly more energy efficient than electric resistant heating because it moves energy from air or groundwater to the heat space. as well as the heat from purchased electrical energy. When the heat pump is in heating mode, the indoor evaporator coil switch role and become the condenser coil, producing heat. The outdoor condenser unit also switch role to serve as the evaporator and discharge cool air, cooler than the ambient outdoor air. Air source heat pumps are more popular in milder winter climates because heat pumps become inefficient in more extreme cool. This is partly because iron on the outdoor unit heat exchanger coil, which block airflow over the coil. To compensate for this, the heat pump system must temporarily switch back into the regular air conditioning mode to switch the outdoor evaporator coil back to being the condenser coil so that it can heat out and defrost. Some heat pump systems will therefore have a form of electrical resistant heating in the indoor air path that is activated only in this mode. In order to compensate for this temporary indoor air cooling, which would otherwise be uncomfortable in the winter.
Third, I will explain evaporative cooling.
Evaporative cooling. In very dry climates, evaporative coolers, sometimes referred to as swamp coolers or desert coolers, are popular for improving coolness during hot weather. An evaporation cooler is a device that draws outside air through a wet pad, such as a large sponge soaked with water. The sensible heat of the incoming air are measured by a dry bulb thermometer is reduced. The temperature of the incoming air is reduced, but it is also more humid, so the total heat, sensible heat plus latent heat is unchanged. Some of the sensible heat of the entering air is converted to latent heat by the evaporation of water in the wet cooler packs. If the entering air is dry enough, the result can be quite substantial.
Last, I will explain free cooling.
Air conditioning can also be provided by a process called free cooling, which uses pumps to circulate a coolant such as air, water, or a water glycol mixture from a cool source, which in turn acts as a heat sink for the energy that is removed from the cool space. Common storage media are cool outside air, the aquifer, or a natural underground rock mass accessed via a cluster of small diameter boreholes. Some systems with small storage capacity are hybrid systems, using free cooling early in the cooling season, and later employing a heat pump to chill the circulation coming from the storage. The heat pump is added because the temperature of the storage gradually increases during the cooling season, thereby declining its effectiveness. Free cooling systems can have very high efficiencies and are sometimes combined with seasonal thermal energy storage (STES), so the cool of winter can be used for summer air conditioning. Free cooling and hybrid systems are mature technology.
In conclusion, I am discussing about the conservation of energy principle, first law of thermodynamics, second law of thermodynamics, classical thermodynamics, and statistical thermodynamics. I also explained some operating principle based on air conditioning system, that is refrigeration cycle, heat pump, evaporative cooling, and free cooling. Thank you for watching.